Hello everyone, I am Dr. Rajesh, working as Assistant Professor in GMN College Ambala Kent. I am with you again with my new video lecture, and in this we will study an important concept. The concept is velocity from infinity. So what do you mean by velocity from infinity? As we will understand, firstly we shall see its definition, and the definition from velocity is given by this one. When a particle moves under central force, under the effect of central force, the velocity that it would acquire if it is moved from rest at infinity to that point, it is called velocity from infinity. Means if a particle is at infinity, means at very large distance, and there it is at rest, and if that particle is moved from infinity to some particular point, the velocity in that period it acquires is known as velocity from infinity at that particular point. Let us see this figure. In this figure, say this is an ellipse. We have already stated that this is an ellipse. Say this is infinite distance and particle is here at rest, and this elliptic is orbit is under the influence of central force. So this 3 is the center of the force. Now this particle is coming from infinity to that point, from infinity to that point. Say this is infinity. The velocity that it will acquire in coming, and at infinity it was at rest, the velocity it will acquire from coming from infinity to this point, say P, which is an ellipse, or any point, the velocity that it will acquire in traveling this much distance, that is distance from infinity, is called velocity from infinity. Okay, now I think definition is very much clear. The velocity acquired by the particle when it is moved from infinity to some particular point under the influence of central force, then that much velocity is called velocity from the infinity. Now we shall derive the equation of the velocity from infinity. From pedal equation of the central orbit, we know that h square p cube dp by dr is equal to f. Okay, fine. H is a constant quantity, dp separating the variables, simply separating the variables. Now integrating both sides, h square dp p cube f dr plus c. This implies that h square p, now I have done the integration. This is f dr plus c. This implies that h square p minus 2 minus is equal to f dr plus c. This further implies that h square 2p square minus integral f dr plus c. This implies that h square by 2 p square is equal to minus f dr minus c. This implies that h square 2 p square minus f dr plus c1, and where c1 is assumed as a new arbitrary constant which is equal to minus c. Now we know that p v is equal to h. This implies that h by p is equal to v, using in 1, using this in 1, this h by p will be v square. We get v square by 2 is equal to minus f dr plus c. So this is the expression of velocity. And when the particle is coming from infinity to some particular point p, say the particle is coming from infinity, so it is coming from infinity and coming to this particular point p, and say this distance is a. So particle is coming from infinity to a. These are the limits on r. So using these limits we get v square, limit is from infinity to a and minus infinity to a f dr, and arbitrary constant will be removed when we are using the definite integral, so this will be removed. Okay, this further implies that velocity at r is equal to a minus velocity at r is equal to infinity upon 2 minus infinity a f dr, and velocity at r is equal to a is at point p minus velocity at r is equal to a is velocity at infinity upon 2 minus f dr infinity to a. This further implies that velocity say at point p is v, and velocity since the particle was at rest at infinity, so it is 0 minus f dr, because velocity at point p is capital V and velocity at infinity is 0, implies v by 2 is equal to minus infinity to a f dr. This implies that velocity from infinity is equal to infinity to a dr. So this is the expression for velocity from infinity. So this expression we will be using in solving the next problem, and this is an important concept. So in this lecture we have discussed the concept of velocity from infinity and derived the formula for velocity from infinity, and in the next problem we will be using it. So if you like the video, please like, subscribe, share and comment. This is Dr. Rajesh saying you goodbye. Keep studying. Thank you very much. Thank you for watching.